Mr. Statsman, I wanna pass. So help me pull this answer out of my ass. 20% of people need a discount. So find the interval and don't you miscount. Statsman, look at the interval. But keep your mind, you can't accept the null. See, it contains 0.2, but infinitely more values too.
Kyle break.
Part A. Consider the interval 0.15 plus or minus 0.06. Part 1. Does the interval provide convincing evidence that the program is not working as intended? The interval does not provide evidence that the program is not working as intended, because the interval, 0.09, 0.21, contains 0.2, which is the proportion that we are looking for. Part 2. Does the confidence interval provide convincing evidence that the program generates the discount with a probability of 0.2? No. This interval does not provide evidence that the true value is 0.2. Because this is an interval, the true value is only statistically proven to be somewhere in the interval, not specifically 0.2.
Mr. Statsman, there's still more. What happens when n is multiplied by 4? Well, it's proportional to 1 over root n. I guess we know the error is 0.03 then. Statsman, interval again. This time it's bigger, so we check it again. 2's fairly distant. It's statistically significant. Kyle break. In the arms of the angel.
Part B. Determine the value of the margin of error based on the second sample of bills that would be used to compute an interval for P with the same confidence level as that of the original interval. Because we know margin of error is proportional to 1 over the square root of n, and we know the previous margin of error was 0.06, we can calculate that the new margin of error will be 0.03.
Part C. Based on the margin of error obtained in Part B, what do you conclude about whether the program is working as intended? Because the new interval is 0.12, 0.18, 0.2 is no longer contained in the interval. This provides statistically significant evidence that the program is not working as intended.